Okay, today we're going to talk about nomenclature, and that means literally the naming system. So for naming compounds, you have to know a couple things. The first thing you need to know is you need to determine the first element, which type of element it is. If it's a metal or a non-metal. So if it's on the left-hand side of the great squiggle, the stair-step line, that will be a metal. If it's on the right-hand side of the stair-step, it's a non-metal. If it's on the stair-step, that's something different. We won't worry about that right now. But determining first if it's a metal or non-metal. All right, so our first scenario is if the first element is a metal, something like KCl or potassium chloride. The K or potassium, that's a metal. So that tells us right away we're going to be using the ionic nomenclature method. So in Schoology, there's an assignment called monatomic and polyatomic ion nomenclature. So the first thing we're going to start with is that one. There's also a Schoology assignment that has to do with molecular nomenclature. We're not going to worry about that because we're only going to worry about right now if the first element is a metal. So the example that I give you here has this worksheet has some questions at the top. We're going to hold off on those questions. The one thing that it does have has table E. Table E can be found in your reference tables. It's on the second page, and it is a table of selected polyatomic ions. It's some of them, not all of them. And one of the things you might notice right away is that many of them end in either ATE or ITE. All right, ate or ite. Yes, there are some that end in IDE, like cyanide, all right, and like peroxide, all right, but for the hydroxide, but for the most part, most of them end in ATE or ITE. Those are polyatomic ions. Poly meaning many, atomic, many atom ions. There's another group of ions called monatomic ions, and that's not listed in the reference tables, but I want to have you write those down. That's what I'm going to call table E1. Table E1 is a list of selected monatomic ions. And these include carbide, nitride. So carbide is a carbon with a 4 negative charge. Nitride is nitrogen with a 3 minus charge. Chloride is chlorine with a 1 minus charge. And anytime you make it an ion, you're going to change the suffix, the ending, to IDE. We have oxide, fluoride, and then we have these ones down here, hydride, phosphide, sulfide, bromide, and iodide. I'd like you to stop the video right now, record those on on the left-hand side of table E in your reference tables. Okay, now that you have those done, we're going to move on. So we're going to use this stuff. So the first question is this one here, calcium nitride. And what we're doing is we are given the name, so we have to determine the formula. The formula for calcium nitride is going to be determined in a stepwise fashion. The first thing you want to do is determine the symbol and charge of the cation. The cation is the very first thing. Calcium is the cation. So to do this, you're going to look on your periodic table. All right, so we look on the periodic table. All right, open the periodic table. We find calcium. It's over here. So let me zoom in so you can see a little more clearly. And the symbol for calcium is Ca. The charge, the selected oxidation number, is a +2. So this says to write the symbol and charge for calcium. So symbol is Ca. The charge is 2+. Generally, the convention is to write the magnitude first and then the charge. But if you write the charge first, so if you write +2, that's not going to be the end of the world. No big deal. All right? So there's the first step. The second step just says determine the symbol and charge of the anion. Anion is nitride. Nitride, as we just learned, is one of our monatomic ions. It ends in IDE. All right, nitride is right here. The symbol and charge of that is N3-. So we write N3-. Third step says, you now need to determine what multiple of cation to anion has a charge differential of 0. Essentially, I'm asking you, determine the least common multiple. All right, least common multiple means to count by 2s and count by 3s. So the common multiple for 2s are 2, 4, 6, 8, 10, 12, 14, 16, yada, yada, yada. The common multiples for 3 are 3, 6, 9, 12, 15, 18, yada, yada, yada. The lowest one that they both have in common is 6. So how do we get them both to be 6? Well, the 2, so right now the only thing that I'm concerning myself are the 2 charges, okay? So the goal here is to change the charge to be a common multiple. So to get 2 to be a 6, we have to multiply by 3. To get 3 to be a 6, irrespective of the magnitude of the charge, I'm going to need to multiply by 2. So if you consider this mathematically, I'm going to need 3 positive 2 ions and 2 negative 3 ions to make this equal 0, because positive 6 minus 6, they negate one another. All compounds must have a balance of 0 for the charge. So what we do is we now take the formula. The formula is simply the cation symbol with a subscript. So the Ca, and the subscript tells you how many you need, and I need 3 of them. You now follow that by the anion symbol, which is the N, followed by a subscript telling me how many of those you need, 2. So the formula, the final formula, is Ca3N2. That is the formula of the calcium nitride formula unit. Let's try another one here. Nickel 2 bromide. Nickel 2 bromide. Again, we start with the very first step. Determine the symbol and charge of the cation. Right here I have parentheses. It says, hint, look on the periodic table, and if a Roman numeral is in the name, it tells you the charge. We have a Roman numeral. The symbol for nickel is Ni, and this Roman numeral tells us we have the charge to be 2+. And I know that because the reason it's got to be in there is because nickel has more than one oxidation state. So if we look at nickel here, all right, there's nickel. Nickel has both a positive 2 and a positive 3 oxidation state. Calcium, the last one, only had a positive 2, only had 1. Nickel has 2 different charges. And because of that, we need to identify that. The positive 2 would be Roman numeral 2. The positive 3 would be Roman numeral 3. And so that's why we see a nickel Roman numeral 2 in our formula, in our name rather. So we're going to know that we're talking about the nickel that is the positive 2. All right. We're now going to look at the anion. Again, the anion for bromide, the bromide anion, is on table 1, E1, is Br1 minus. So we have a nickel that is a +2, a bromide that is a -1. Again, we are only concerning ourselves with the charges. The common multiple of 2 and 1 is 2. So to get 2 to be 2, you're just going to multiply by 1. And to get bromide, the -1 to be a 2, you're going to have to multiply that by 2. Just like in math, you don't write a 1 in a formula. All right? You don't write 1x. So we're going to write the Ni. We're going to omit the 1 because it's understood that we have 1 of those. But we are going to write the subscript of 2, identifying that we need 2 of the bromides. So the formula for nickel 2 bromide is NiBr2. Calcium oxide. This one you don't have. So I'd like you to stop it, work through this, and figure out how to do this one. So go ahead and stop it. When you're done, I'll put the answer up here. Is that what you got? If not, take a look at it and figure out where your error was. If so, good. Let's move on to the next one. Tungsten oxide. Try this one. I will tell you that tungsten has an odd symbol. Tungsten's original name way back when was wolfram. So tungsten's symbol is W. I'll give you that much. So work through that. Look on your periodic table. All right. Your periodic table is going to tell you that tungsten, down here at the bottom, in the middle, where is it? Over here. Tungsten is a +6. So I'll help you with that. So tungsten is a +6. If you worked through it and got that, fantastic. Tungsten's a +6, oxide's a 2-. The least common multiple is 6. So we're going to need 1 tungsten. We're going to need 3 oxides to get 6 and 6. So it's going to be WO3. Rubidium chlorate. Rubidium chlorate, very similar. Chlorate tells you have a polyatomic ion, so you'll need to look on table E to find that one. So there they are. Rubidium's a +1, chlorate's a -1. The common multiple of 1 and 1 is 1. So when we write this formula, we're simply going to put both of them together, and we get RbClO3. That is the formula for rubidium chlorate. Aluminum sulfite. Stop it, find the charge and symbol of the cation and anion, and then continue through. There's the cation. There is the anion. Now you need to find the common multiple, the least common multiple. Least common multiple is 6. Those are the ratios. And so now we'll have Al2SO3 3. But that looks as though it says Al2SO33. We want 3 SO3s. So the way we indicate that is we put parentheses around the polyatomic ion. If multiple polyatomic ions are needed, you put it in parentheses. Al2SO3 3. And there, from this point on, I want you to finish these. I'm asking you just to do the first 15, just the formulas.